There are some huge challenges in the world of textile production and how we're using and wearing clothing, and it's to do with raw materials. In 2015, we used the equivalent of 55 million tons of polyester and cotton raw materials to make our clothing. In that same year, we threw away, it's estimated around the globe, about 50 million tons of end-of-use textiles. So in effect, we're throwing away almost as much as we're making every year. We're still not returning high volumes of textiles. In the UK, we're recycling about 60%, but in the US, you compare it to one of the highest consuming countries in the world, they're collecting about 10 to 12% of their end-of-use clothing, meaning that the rest of it is just ending up direct in landfill. Globally, on average, we're only collecting about 20% of end-of-use textiles. 80% is ending up in landfill. So it's a huge loss in these raw materials. Once textiles have been collected, so what happens to that 20%? A textile collector will take it back to a sorting and grading facility, and about 50% of it will be suitable to be reworn again. So it gets resold as clothes. It can be in local markets or sent off to sub-Saharan Africa or Eastern Europe, where it can be reused there as well. But of the remaining 50%, about 40 to 45% won't be rewearable. It can go for downcycling, it can be reused in other kind of lower value products, like insulation, it can get shredded up into industrial wipers, all sorts of different uses. So things are happening with it, but they're lower value products that once they get used again, there's no collection system to recapture them as textile raw materials. Accessing these resources is going to be a challenge in the future. We're going to need our land to grow food. The population is set to increase to 9 billion, 8.5 to 9 billion people by 2030. So we're going to need this land to grow food for people rather than using it to grow cotton. So if we're using new virgin raw materials every year, but we're throwing them away at the same time, it doesn't make sense. Surely there must be a way to recapture those raw materials and cycle them back into new textiles.
So there's cotton, which is a natural material which is made from a polymer called cellulose. Now, cotton is a natural material, but it's also very resource intensive. So it uses a lot of land, it uses a lot of water, and it also needs fertilizers and pesticides which are put on the land. So it's very resource intensive. Polyester, on the other hand, it's a man-made or synthetic polymer. It's ultimately sourced from oil that needs to be extracted from the ground, it needs to be refined, and it needs to be turned into the synthetic polymer. Now, both cotton and polyester are therefore very resource intensive, and as demand for textiles increases, demand for cotton and polyester will be going up, and there just won't be enough resources to support this kind of economy. So essentially, we can think of the waste cotton and polyester as a sort of new resource which can be tapped instead of using the resources which will deplete, the energy costs which will be going up, the land which will be running out. So we have a real opportunity there.
We didn't start with the textile recycling, we actually started with wood pulp spinning. So we tried to find new ways to valorize wood here in the Northern Hemisphere, in particular in Finland. So we developed a process that is capable of turning wood cellulose into textile fibers. And as we developed the process, we noticed that it is quite robust. So we tried to feed in less pure material, and starting from less pure wood pulp. And at some point we reached that textile fibers. And we noticed that also waste cotton can be transferred into entirely new textile fibers. And once we realized that, we started to focus more on this research area, and then teamed up with other institutions that were also focusing on textile recycling, as obviously this is a long process chain, and this is how it all started.
When recycling textile waste, we first have to make sure that it's cotton only. That means that if we get some fabric, we have to remove buttons and zippers, and then we have to do some easy pretreatment in order to adjust the material's property to our spinning process. And this involves non-toxic chemicals being also used at the hairdresser, for example. And then once this is done, we can dissolve the fibers or the cellulose into some ionic liquid, which is some low melting point salt, meaning that compared to, for example, table salt, sodium chloride, it has a very, very low melting point, even below 100. In our case, it's 60 degrees, and that is very favorable for our process. In the spinning process, we first load the cellulose solution into this cylinder, and in the cylinder there is not only the spinning solution, there is some piston which can apply very high pressure, and at the bottom of the cylinder there is some sieve, or as we call it, spinneret. It has a lot of tiny holes. In this case it's 200 holes, being smaller than 1 micrometer, and through that we apply pressure, and then the cellulose solution is extruded, which means that it's dropping through this sieve into the water bath. And in the water bath it coagulates again. And coagulation means that it solidifies again, because cellulose is not soluble in water, but ionic liquid is. So we wash away the ionic liquid and get the fibers. And from this point in the water bath, we can then take the fibers and wind them around this roller down there in the water bath, and then over to the godhet. Because in order to get fibers which can be used in textile industry, we need quite thin filaments. And we can only achieve that by stretching the filaments or the fibers even more. So what's happening in the end is that the speed of the godhet is 12 times faster in our case than the speed of the fibers being extruded into the water bath. And after that, we can collect the fibers. We will wash them in order to remove the rest of the ionic liquid in there, and then we open them just using our hands, because we don't have any suitable device for that yet, but for lab scale it's okay.
Probably one of the most impressive achievements that we had so far was the nomination for the Global Change Award that we received last year in 2016 on the specific topic of textile recycling.
Has developed a technology for using solvents to separate the components of end-of-life textiles. So you can imagine when people are finished with their clothes, they all get mixed together. There's a lot of different materials, and the worn-again process uses solvents to selectively recover individual components of the textiles, particularly polyester, cotton and dye stuffs, colorants. And when it's recovered these different materials, it separates them to a very high degree of purity, and they can then be recycled, regenerated and sold back into the supply chain.
Part of our process is dye stripping. Here we want to use a solvent which is selective for the dyes in particular in order to remove them from the fabric. So what we can see in this small lab scale demonstration is that we're taking 3 different colored textiles and placing them into some solvent. As the solvent and the textiles stir, the dye is extracted into solution. Once we take the textiles from the solution, we can see that the dye has remained in the solvent and is now in a liquid state. If we want to then recover these dyes at the end of the process, we can essentially just evaporate the solvent and recover the dyes as a sort of solid or semi-solid material. Another part of our process is polyester extraction. In this part of the process, we use a solvent which is selective for polyester specifically to extract it from textiles. In this example, we're using polyester fabric, and what we're going to do is put it into a solvent. As we're putting the fabric into the solvent, we can see it start to break down, disappear, and eventually dissolve. As we add more fabric into solution, we can also see it turn a little bit cloudy. This cloudiness is another impurity called titanium dioxide, which makes the solution slightly cloudy and which can also be removed. After we've done this and after we've placed all the textile into the solution, we have a solution of polyester. We can then remove the solvent and recover polyester as a sort of powder, which can then be pressed to form pellets, and then we can use these pellets to form fibers. These fibers are formed by melting the polyester pellets and extruding them. Another part of our process is where we dissolve and extract cellulose, aka cotton. In this example, what we're doing is taking essentially shredded post-consumer cotton and dissolving it in our solvent. So we take the shredded cotton and place it in the solvent and mix it up. As we start to mix it up, the viscosity starts to increase rapidly as the cellulose goes into solution. After a while, the solution becomes a lot clearer, and essentially we have what is called a dope. And this is a solution of cellulose in the solvent. And we can then make two different products from this. One is a kind of cellulose powder or pulp, which we can give to cellulosic fiber manufacturers to make their own cellulosic fibers. Or in the second path, we can use this dope to make our own cellulosic fiber from this specific solvent.
The whole idea of circular economics, when you apply it to textiles, the word economics is in there. Yes, it's more sustainable. Yes, it's more environmentally friendly, but ultimately, it's the economics that will drive this. Because in the future, in the not so distant future, it will be cheaper to make our products, make our clothing out of existing raw materials rather than use virgin resources. There's going to be a huge fight for virgin resources, for land, for water, for energy. We need to put that elsewhere. We need to use that for doing other things. If we can make all of our new clothes out of existing raw materials from existing textiles, why wouldn't we? It makes good sense. And if we can do it cost efficiently, cost effectively, then it's a no-brainer.
I think that one of the biggest issues we have is actually perception. Words like chemical and solvent conjure up a fairly negative image amongst large chunks of the general public. And one of our challenges is really to show and to convince people that what we are doing is not only environmentally friendly and benign, but also that it can bring real benefits to society and to the wider environment. And a lot of that is to do with changing established mindsets. Actually, from my perspective, much more than it is to do with specific technical challenges associated with process aspects in the laboratory.